Welcome to Algebra 2. My name is Mr. Royce. I'll be your Algebra 2 instructor today. Let's look at example 5 for the 1.5 lesson. Now, if you're having trouble seeing because of the camera, feel free to move around, do what it takes to see what's going on. This is the original inequality. Now, the new abbreviation for today, and we'll look at these abbreviations more in depth. This is not the last day to get exposure to this. We have seats all over the place. Feel free to grab a seat where you can see what's going on. The new abbreviation is absolute value property. You've maybe heard of the zero product property in Algebra 1. This is the absolute value property used whenever there's absolute values. And there's an absolute value property for greater than and for less than. Now, heads up, when you have the absolute value property with a greater than symbol, use the word or. When you have absolute values with a less than, I don't want you to just memorize this, but next week we're going to find out why you use the word and when it's absolute value less than or less than or equal to, and the word or when it's absolute value greater than or equal to. So, for now, realize that's how you can tell whether it's an and problem or an or problem. And I'm going to move the camera just a little bit closer because there's this weird light effect that occurs when it's not focusing just right. Okay, so now we're in good shape. So, absolute value property for greater than means we are going to use which word? And or? Class? Or. Yeah, greater than is or. So here we go. This will be a little bit of a surprise because this has been crash and burn for some students in the past. You're going to see something a little unexpected here, but it's amazingly logical. We're going to take the number that's inside absolute values. It happens to be the number 2x minus 5. Some students make the mistake of saying, oh, absolute value, change negative to positive. No, that'd be a mistake. Don't change that negative 5 to a positive 5. That's where students have tripped up in the past. Instead, think of the whole thing as a number. And here's the logic. That number, 2x minus 5, is greater than 3, or, write the word or really clear. This is an or problem. Or the opposite of that blob, that number, that expression, negative, parentheses, 2x minus 5 is greater than 3. Here's the thinking. The thinking is that, like for example, when you have the absolute value of a number x is equal to 10, there are two cases. Either x is equal to 10, or what's another possibility? If you think of all the numbers whose absolute value is 10, 10 is one number whose absolute value is 10. What's another number that comes to mind? Yeah, it could be x equals negative 10. So it could be that number in there is a positive number or it could be a negative number. And that's all we're saying here. If it's a positive number, then you don't have to do anything to take the absolute value. But if 2x minus 5 is a negative number, and for some values of x it might be negative, then we would take the opposite of the number. Just like the opposite of 10 is negative 10, the opposite of 2x minus 5 is negative quantity 2x minus 5. Now, here's where we're going more in depth to protect you from error. Whenever you're using absolute values, there's going to be two columns of work, and the right column always starts m negative 1. We're not going to distribute the negative sign. Many of you might want to distribute, don't do it. Instead of distributing the negative sign, multiply both sides by negative 1. Remind me, what is negative 1 times negative 1? It's positive 1, so that means that the next line is 2x minus 5 is less than negative 3. What gives me freedom to flip the greater than sign to a less than sign? Since whenever you multiply by a negative or divide by a negative, you reverse the inequality. So that's m negative 1. And now, both are the same. We're going to A5, D2 in the right column. We're going to A5, D2 on the right. The only difference between these two columns is that this column started with an m negative 1, as it always will when you're using absolute values. So We have 4 sections of algebra to fill in. Add 5 gives you 2x is less than 2. Divide by 2 is x is less than 1. Would you please do these 2 lines over here? The left column, go ahead and complete that. When you're done, look up here. So, we have to solve the inequality. And we're not done until we write either an and statement or an or statement. Just like in the homework that was due today, we're going to write, and to make room for it, since I have to write big enough for everyone to see, I'm going to shrink it down just a little bit, taking off that piece because that doesn't have to be there. That was just for teaching purposes. So here we go. The solution is, put them together with an or. X is greater than 4 or x is less than 1. Box it, red box it if you have the capacity to take notes in color. That's the solution. But just like yesterday, we're going to go to a graph because it says graph the solution. So here's the solution. Now the rest is just like the homework that was due today. We do above the number line work in dark purple and light purple. Oh, we got a little bit of a glitch there. That's okay. That's a signal to me that I should probably save my work. Sometimes the computer gets overwhelmed by the number of things it has to remember. But we're good now. So we've got 1 and 4 are the boundary values. Greater than 4 in dark purple, less than 1 in light purple. Hello. Now, with the word or, do I look for the overlap between these 2 purples to get no solution? Or do I just combine the 2 onto the number line? Which is it, overlap or combine? Do I just combine them together into 1? So class, when I say go, I'd like you to say overlap or combine. Which is it, class? I hear some people saying combine. There's not a lot of confidence there. If it were the word and, then I would look for the overlap, which there is none, so it would be no solution. But because it's the word or, we just combine the 2 purples into 1 number line. It's this and that. That is the graph of the solution. But would you please exclude the above the number line work so that you see, okay, this is the graph. This is the lead up to the graph. Any questions on how to get to the graph of the solution? Now, see if you remember the interval notation. Go ahead and express the answer in interval notation. And then tuck your interval notation into set notation. X is an element of the set. Is there anyone willing to tell me what you think the interval notation is for example 5? It was just on the homework that you did today. Who'd like to give this a go? What is the interval notation? All right, thank you so much for volunteering. I give myself till the first unit test to learn all the names. Joseph, you're on. Left parentheses. Yeah. Well, wait, hold on. We have 2 intervals. So there's a green interval over on the left. One. Then parentheses. Good. That's the first one. Then we use that union symbol. And now, Joseph, what is the second interval, the one that corresponds to this green splotch? You got the first interval. You got -infinity to 1. What's the second interval? Parentheses. Excellent. Parentheses 4, infinity. Just like on the homework that was due today. So you realize that the new material is just going from the beginning to this first line. That's the only new thing. Everything else is like last night's homework. That's kind of refreshing. So greater than or. Now let's do a lesson example. So in terms of, We are tight for time, so I want to make sure you get the key examples of the new ones. Oh, by the way, if it were just plain equal sign, that would be an or. It's basically always the word or, unless you see the less than symbol. So let's go to example 7. Let's do our first example of what to do when there is a less than symbol. Well, the truth is, we have to do some preliminary work with this OI original inequality before we really do anything with absolute values. Let's just get that 3 out of there. So the 3's got to go. So we're dividing both sides by 3 to get, as expected, the absolute value of x minus 9 is less than or equal to 9. Okay, so no surprises there. Now that we've isolated the absolute value, it's time to use the absolute value property for less than or equal to. So here we go. The abbreviation is absolute value property for the less than or equal to symbol. This will be an and statement instead of an or statement. This is actually really exciting to me to see how much you're leaning into this. Wow, this is a big contrast. Last year, I could tell people, I didn't notice at the time, people were overconfident. I've got this. I saw this before. All right, so this time, it's going to be the stuff inside absolute values. That number, think of x minus 9 as just a unified number. There's 2 cases. X minus 9 is either less than or equal to 9. This time it's the word and. Or the opposite of that number. And the other possibility is that the opposite of parentheses x minus 9 is less than or equal to 9. Okay. The only one that gets m negative 1 is, you tell me, is it the first column that starts with m negative 1 or the second column? Class? I'm sorry, what? Yeah, it's always the second column. So that one, we're going to start out with m negative 1, and then we'll do the a9. The first column is just a9. So I'm asking you to fill in 3 inequalities. Please try the a9 inequality over here, and try the m negative 1 a9 inequality on the right. Please try those on your own. A9. I don't know what you came up with, but I came up with x is less than or equal to 18 and x is greater than or equal to 0. Raise your hand if that's what you came up with when you did these 3 steps. So, you have not solved this problem until you write x is less than or equal to 18 and x is greater than or equal to 0. That's the solution. We might be able to condense that after we look at the interval notation, but there's a solution. Any questions on how to get that? Thank you for the humility you're expressing to learn something a little bit new, even though you've seen this stuff in the past. Now, let's do the above the number line work. Labeled X. Please fill in, write down what you think my purple, dark purple and light purple work is going to look like. Before you go on the number line, go above. Okay. Well, light purple. Now go on the number line. Go ahead and combine these two into one, or we'll actually do the work and decide, am I going to just combine them to get everything from negative infinity to infinity, or am I just going to look for the overlap? Which will it be, combine or overlap? When I say go ahead and respond as a class. Let them hear you out there on the World Wide Web. So here we go. Which is it, overlap or combine? Class? Overlap is correct. They overlap from 0 to 18. So that's the graph of the solution, which means now try the interval notation. When you're done with the interval notation, look up here. See if we're in agreement. Any questions on how to get square bracket 0, 18? Right square bracket. We good to go? Those are the hardest two parts of the homework that's due on Tuesday. I'm going to fill in the notes for the other ones, so if you're like stuck with the equal sign case, you can do that, but hey, it's time for the quiz. Now, for the quiz, we've got two different versions of the quiz, so that that way you won't be temptation to look to your left and your right. It's like they've got a different quiz, so just focus on yours and you should be good to go. So let's begin with the quiz. And when you're done with the quiz, please go on your Surface and take the calculator survey. This is calculator allowed. I don't think you'll need your calculator, but if you want to use a calculator, you can use it on the quiz. Go ahead and put all papers away, notes, notebooks, even these notes. Everything's got to go away. And Serena, for the quiz, I want you to come sit up here. Okay? All right, here we go. As soon as I give you the quiz, you may begin.